What we have here is the fire extinguishing robot, the FEV. When you turn it on, it goes into standby mode. It blinks a light every 5 seconds to let you know it's powered on and it's detecting, and it has plenty of power.
Okay. Alright, when it's in standby mode, it's waiting for a smoke signal to turn it on. And there it goes. Now it's going to start searching for a fire.
It'll drive forward until it sees an obstacle with the IR sensors that are crossed in the front. If it detects something, it'll turn whichever way it needs to until it loses it and turn an extra 60 degrees and then go back into driving straight.
Alright, when it's searching for a fire, it has infrared sensors that should trigger about 1.5 feet away from the wall and turn and avoid any obstacles.
If at any time the 180-degree viewable UV flame sensor triggers, it will shut the veil, limiting the view to 10 degrees. It'll go and say pinpointing fire, and it'll turn right 90 degrees and then left until it sees the fire again. It'll then drive forward, and if at any time it loses it, it will reorient itself towards the flame and then keep driving forward until the IR sensors trigger along with the UV sensor. At that point it goes into retarding mode and it'll spray water and put out the fire.
It's going to start searching for a fire. And when it sees it, the veil's going to close. And now it sees it through the veil, so it's going to go straight for it. That's the trouble with the hump. Alright, so when the sensor sees the fire and the IR detectors get tripped, it will activate the pump and put out the fire. And then it goes back into searching mode.
It also has equipped front headlights that work with photoresistors. When the ambient light level gets low enough, it'll trigger on the front headlights as well.
Right, so when the light goes below a certain level, the headlights turn on. You can change the light sensitivity with this potentiometer here.
Yeah. Always works.
There.
Yeah, see.
So when you do it just below, you can cover it with your hands. It's sensitive to shadows. Alright, on the inside here we have our main board. This is going to be the drive pick right here. Everything else connects to it. These are two analog to digital interpreters for the IR sensors. On the back we have a pick interpreting the signal. It's an analog signal coming in from the smoke detector. We also have a pick to run the lights and a separate one to run the LCD. I think there's 7 total. And this is our sound chip. It has the pre-recorded siren on it. Alright, to power it we have one 12-volt lithium-ion rechargeable battery, and that powers the servos, the 2 drive servos here and here, and then also the veil servo up here. To run all the circuits we just have a 9-volt. We did separate batteries because the current draw from this pump would cause all the logic to restart. We have two voltage regulators, one 6-volt to do the servos and one 5-volt for all the circuits. For the 2 drive servos, we actually had to take them apart. They're only designed to turn 90 degree or 180 degrees. We had to take them apart and modify them so they could turn 360 degrees. You have to disconnect a potentiometer and trick them to where they always think they're turning left and they will just drive continuously. Yeah, we still send them the standard pulse width modulation signal to turn them left.